That's right, it's your boy, and I'm back with a new mic. And today I'm going to be going over the VEXcode VR for coordinate numbers. I would like to go over referencing your bot's position, as well as thinking about how we can calculate that manually. Let's get into it. This is harder to do now. Yeet. All right, guys, so I realized what I did wrong. Um, I had the default mic be the mic here in the camera instead of this wonderful microphone I got. So I got this extension so I can have this microphone all up in my grill just to make sure you guys could hear me. But it wouldn't have mattered at all if I didn't check my settings. So check your settings first. All right, anyhow, here we are in coordinate numbers. And this time I'm asking you guys to move to a specified coordinate, just like it's a Cartesian coordinate. Okay, and we want to know which of these numbers it is. Now you could just respond and guess a number 1 to 100, but you've got a 1% chance of getting that right. So I don't advise that. But as a mathematician, it's a mastery system. You could just try 100 times. Anyhow, please don't brute force this. Let's go into the VEXcode VR interface and work on it. Here we are in VEXcode VR, and oh my God, is that zoomed in? Let's zoom out a little bit so we got some room to work, okay? So we're going to want to make sure we are on the number grid map. So let's look at our playground. Not the grid map, but we want the number grid map. Move that over here. Give myself a little bit of space to work with. Now our assignment says we need to get to negative 500 millimeters, 700 millimeters. So you'll notice I'm all the way down here at negative 900, negative 900. So neither the X nor the Y position is correct. Let's try brute forcing this and doing it the hard way. Let's drive forward, because I certainly need to be higher up. And let's try doing it for 200 millimeters. You'll notice as we move forward, our Y position is changing. It's becoming a smaller Y position because we're moving forward in the Y direction. Let me try like this. Is that a little bit better? You guys can actually see my face. Maybe I should do this. All right, perfect. So let's go ahead and move forward a little bit more because we just kidding. All right, let's move forward a little bit more because we want to get to the Y value of positive 700. Now we could just inch forward 200 millimeters at a time, or we could notice that, well, we moved from negative 900 to negative 700. We need to go from negative 700 all the way to zero, past zero to positive 700. So we need to go another 1400 millimeters past 200. So we need to go 1600 millimeters, quick maths. Let's try that. Boom. So now we have the correct Y position. Now we need to get the right X position. Yeah. Literary term. Anyhow, we're certainly going to need to turn right and move to the right. So let's turn right for 90 degrees. So we're facing our robot, let's say east per our north or original orientation. So together this should look like moving forward and then turning right and facing this direction. From there, we're going to need to move to negative 500 millimeters. So quick math says, well, we just need to move 400 millimeters. I should give you a different coordinate. Okay, actually face. Whoop, whoop, whoop. I keep it running like a baby. It's talking like a... All right, actually phase. I'm not going to have you guys go to negative 500, 700 millimeters because I'm going to have you guys do it. I'm not going to do that because that would just give you the answer. So let's instead go to 300, 400. That should be easy enough for me to remember. Cue the video to like 20 seconds later when I forget. So 300, 400. You'll notice we here are at negative 900, negative 900. Well, 300, 400 is certainly greater than that. So let's just start by moving forward and see what happens. We move forward 200 millimeters. Oh, I noticed my Y value changed by increasing, adding 200 millimeters. Well, if I want to go to 300, 400, well, we've got another 700 to go in the negative. And then if my 400 needs to be our Y direction, we got 400 to go in the positive. So 700, 400, and the 200 we've already gone is going to be 700, 200, and 400. It's going to be 1,300 millimeters. Let's see if the math teacher can do math. Oh, we're having a good time trying to remember 300, 400. All right, so now we have a y position of 400. Perfect. So now we get to 300 in our x position. So literary jokes aside, let's turn right so that we're looking to the right. So this should look like forward. And then at the end, once we get to 400 in the y direction, we'll turn right so we can actually move forward in the x direction. Let's move forward in the x direction. Now I want it to be at 300, 400. We know from moving in the y that we'll have to pass the negatives first and get to the positives. So we need to go 900 in the negatives and then another 300 in the positives. So we need to go for a total of 1200 millimeters. Okay, so now we've arrived at 300, 400, and the question asked us, which number are we on? 67, 77. This is unscripted. Obviously, your puzzle will give you a integer value. You won't stop between two. So this would be a very simple solution, except for it's not your solution. I want to show off a little bit, so let's circle these, okay? Both the 77 and the 67. Now, I want to see how much, let me, by the way, set my drive velocity a little bit faster so this doesn't take as long. 600 drive velocity, 600 turn velocity. This should just speed up this whole process so I don't have to edit with speed ups as much. Oh, he stole my Jenga jam. Okay, so let's try this again. Zoom, a little bit faster this time. So we're going to where we were. I would like to go a little bit farther because I want to get out to a point where I'm equidistant from the 77 and the 66. So let's turn right for 90 degrees, and I want to just inch towards that. Let's see if those are 200 millimeters apart, as I suspect they are. Okay, so I'm directly on top of that. And if I were to now, let's just pull this aside because we're just theory crafting here. If I were to turn around, so let's use a new command. Turn to heading. Notice I'm heading 180 degrees right now. I want to turn to heading 0. So that means just turn directly around so I'm facing north. And then I want to drive 200 millimeters to confirm that these two are 200 millimeters apart. Let's do that. Oh, okay. Let's put that at the end of our string. Herp to derp. So at the end of this, we should see the robot will go down to 66, then up to 67. Sorry, 67, 77. There we go. Okay, so we do know the radius of the circle, at least if it were to hit these directly on their head, would be 200 millimeters. So let's make a 300 millimeter circle. That means I want to drive forward just a little bit more. And now I want to start walking around in a circle, so I circle these two numbers. Okay, so I know my circle radius is going to be 150 millimeters. So let's do some quick maths, okay? Bring up my calculator. I have a radius of 150 millimeters. I need to walk all the way around that. So I need to know the circumference of that circle. So the circumference is 2 pi r. So 2 times 3.14 times, we said we have a 150 millimeter radius. 942. We need to go 942 millimeters around our circle.
So much later that the old narrator got tired of waiting and they had to hire a new.
And everyone can screw up. This is an instance where Mr. B screwed it up a few times, once with an example, and secondly with saying 76 and 66 because I misspoke, and then thirdly because I set the print color to red instead of the robot pen color to red. So this will give us, and let's move the robot off here, drivetrain, drive, let's pull up that pen and move forward a little bit so Mr. B can see what I did. So we're going to move the robot pen up, stop writing, and then we're going to just move forward for 200 millimeters. That way, though. All right, Mr. B, why did you spend so much time making a circle? Well, because I want to show you guys how it's useful to use math, the math that you've learned in your classes, to incorporate into robotics so that you can do relatively cool things that you'll actually need to do with your robot in programming. Something that would have been super tedious to do with a million tiny little steps, we can do with a repeat command. Um, Also, to more humorously illustrate what I did wrong. Thanks so much for stopping by, and if the audio has improved, which I certainly, fingers crossed, hope it does, then please let me know in a comment below, or just like the video, give it a thumbs up. See what I did there? Have a great day, everybody. Bye-bye!